Hello again, Professor Jared here. Welcome to Module 3, which is focused on population genetics and molecular biosystematics. So, for our next two lessons, we're going to hone in on how populations evolve. Fundamentally, we're going to be thinking about microevolution. That is to say, why do allele frequencies change from one generation to the next? Today, I'm going to introduce one of the foundational principles of population genetics: how to apply the Hardy-Weinberg equilibrium equation to solve for both allele and genotype frequencies. In other words, it's the dreaded math in 182. Don't worry, I am here to really walk you through it step by step. We're going to break it down and hopefully make it easy for you. All these beautiful koi fish here, these are a type of carp, an Amur carp. These guys are going to be your animal model in this week's laboratory, which is called PopGen Fish Pond. So this is where you're going to systematically violate each of the assumptions of the Hardy-Weinberg equilibrium equation to visually see how populations evolve. The Hardy-Weinberg equilibrium equation was independently derived, meaning both of these dapper gentlemen, they came up with this equation on their own in 1908. It was developed by a general practitioner and obstetrician, Wilhelm Weinberg, who's on the right, and then a Cambridge mathematician, a brilliant mathematical mind, G.H. Hardy on the left. So the Hardy-Weinberg equilibrium equation states that both genotype and allele frequencies will remain constant. They won't change. They will be in equilibrium from one generation to the next unless acted upon by disturbing factors. And we're going to talk about those disturbing factors here shortly. These are factors like natural selection, so differential rates of survival and reproduction, which we know causes evolutionary change, or migration or mutation. All of these disturbing factors we're going to discuss in depth in Learning Activity 5.2. Essentially, what the Hardy-Weinberg equilibrium equation demonstrates mathematically is that sexual reproduction alone, i.e., the recombination of alleles that occurs because of meiosis, the creation of the gametes, and then fertilization, the fusion of the gametes, sexual reproduction in and of itself is not enough to cause a population to evolve.